Hello friends and my dear students, I welcome you all to my channel. This is set number 2 on the chapter of exponents of 10 good problems. I've already completed the set number 1 on the chapter of exponents. So 10 questions are already completed. If you have not watched the set number 1 video of solving the 10 good problems, I highly suggest that you watch that video. This video is part of the playlist Maths 8 HOT. HOT stands for High Order Thinking. In this series of videos, I will keep on preparing and solving 10 good problems from a chapter, uh, so that you will have a good exposure of testing your understanding of the chapter concepts by solving the 10 good problems in roughly 30 or 40 minutes. So ideally you should give 3 minutes per problem to solve the problem. Okay, so if you are new to my channel or not yet subscribed, and if you are visiting my channel for the first time, or seeing this video for the first time, and if my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's start solving the 10 good problems of set number 2 on the chapter of exponents. Okay, so I have the 10 problems on the left hand side. I hope you can it's visible, you can see it properly, and on the right hand side I will solve the problems. It is always recommended that you try to solve the 10 problems yourself. Give multiple attempts. Only if you are not able to solve, you can see this video for the solution. And while I will be solving the problems, I will pause for a few seconds after solving a problem so that you can take a screenshot of the solution. So let's start. Okay. And it is also highly recommended that you solve this problem once you have completed the chapter and you have a good practice of solving a lot of problems from your textbook or even other reference books. Okay. The first problem says, on the left hand side there is an expression given in terms of exponents and a. On the right hand side it's an equation. On the right hand side there is k multiplied by a to the power m, where k is a rational number and m is a positive integer. So in this equation, the given equation is 25 multiplied by a raised to the power minus 4 divided by 5 raised to the power minus 3 multiplied by 10 multiplied by a raised to the power minus 8 is given to be equal to k, where k is a rational number, and there is nothing said about a, so we need not bother about a, and m is given to be a positive integer. So if this is the equation given, we have to find the value of k to the power minus 1, that is the product of reciprocal of k and m. We have to find this value, that is k raised to the power minus m multiplied by m. We have to find this value. Okay, so let's see. Now for this kind of solving equality, you can see that the right hand side is a product of a rational number and a exponential term. By exponential term I mean any rational number raised to the power having some power, x to the power m, where m is a integer and x is a non-zero rational number. That is what I mean by an exponential term. This is an exponential term, x to the power m, where m is a integer and x is a non-zero rational number. So ideally the strategy that we need to follow is that we have to convert the left hand side in the form of a single exponent, and possibly it will have some quotient, just like on the right hand side the coefficient of a to the power m is k. Similarly on the left hand side, if we simplify the left hand side, we might have some coefficient, or we may not have any coefficient, At least we have to get simplify to have a single exponential term with base a and some power. Okay, so let's using the laws of exponents, let's simplify the left hand side slowly. Now I can see 25 in the numerator 25, and the denominator I can see 5 raised to the power minus cube. So I will obviously try to write 25 as 5 square, and okay, and I can see in the numerator I have a to the power minus 4, in the denominator I have a to the power minus 8. I will merge that using the law of x to the power m divide on the right hand side. As and when I am solving a problem on the right hand side, I will write down the laws or formulas that I am applying. So x to the power m divided by x to the power n is equal to x to the power m minus n. So we have a to the power minus 4 divided by a to the power minus 8. This will be a to the power minus 4 minus of minus 8. And in the numerator we have 5 raised to the power minus 3, and we have 10, we can write as 2 multiplied by 5, and on the right hand side we will leave it as it is. Okay, this implies now if I merge all the powers of 5, in the numerator I have 5 raised to the power 2, so it will be 2 minus in the denominator I have minus 3 and 1. This is at the end if we have 5 to the power minus 3 multiplied by 5, which is basically, okay, let me write down do the solution step by step. Okay, so this is 5 square multiplied by a to the power minus 4 and subtracting minus 8 from minus 4 gives 4. So we have a to the power 4 divided by, and in the denominator we have 5 to the power minus 3 and 5. So we will add up the powers, that is minus 3 plus 1 becomes minus 2. So this is 5 to the power minus 2, and we have in the denominator 2. This is equal to k to the power k multiplied by a to the power m. This implies if I apply the now if I merge the powers of 5, we get 5 raised to the power 2 minus of minus 2 multiplied by a to the power 4 divided by 2 is equal to k a to the power m. Okay, this implies we have 5 to the power 2 minus negative 2, that is 5 to the power 4. A to the power 4 divided by 2 is equal to k a to the power m. So this implies 5 raised to the power 4 is 625 by 2 multiplied by a to the power 4 is equal to k a to the power m. So it is given that k is a rational number. K is a rational number. It is so. This from here we can clearly say that k is equal to 625 by 2 and m is equal to 4. On the left hand side we have a to the power 4, on the right hand side we have a to the power m. So the bases are same. So the the exponential term a to the power 4 should be equal to the exponential term a to the power m on the right hand side. So m should be equal to 4. Let me quickly check if everything is visible or not. Okay. So we have k equals to 625 by 2 and m equals to 4. So this implies what is k raised to the power minus 1 multiplied by m is equal to nothing but K raised to the power minus 1 means reciprocal of k or multiplicative inverse of k, which is 1 by k. So this is equal to m by k, and this is equal to uh, m by k. And okay, let's not okay, so we have this. Now if we substitute the value of k, we have 625 by 2 raised to the power minus 1 multiplied by m is 4. Now 625 by 2, its reciprocal is 2 by 625, and we have multiplied by 4. This is equal to 8 by 625. 8 by 625 is the answer. So this is the result, is the value of k to the power minus 1 into m. So the answer is choice C. So I am pausing the solution for a couple of seconds. You can take a screenshot. Okay, let's do problem number 2. It is solve for x. Okay, so it is also a equation, and we have to solve x. Solve for x, and the equation given is 1 by 10 to the power 2x minus 1. Okay, so this is equal to 5 raised to the power minus 3 divided by 8. So we can see that okay, now ideally we have to, in this kind of problem where we have to solve the unknown, and the unknown is either we have on the both side, left hand side, in the given equation, both the left hand side and the right hand side have some powers, exponential terms, and the unknown is in the power, then obviously we have to convert both the left hand side and the right hand side in a single exponential term, so that the bases are same. And since the unknown x is in the power, then we will equate the power, and from there we will solve for x. The base has to be same on both the sides. Now 1 by 10 to the power 2x minus 1, we know is that 1 by something is 1 by x, where x is a non-zero rational number, is equal to x to the power raised to the power minus 1. So this is equal to 10 raised to the power 2x minus 1, this whole raised to the power minus 1 is equal to, now we can see the right hand side, the numerator is in the rational form, p by q, where p is 5 raised to the power minus 3 and q is 8, and we can see that p, that is the numerator, is in the exponential form. It has power 3, it has power minus 3, and we know that 8 can be written as 2 to the power 3. Okay, now this implies that we have to make the base same. We have to make the base both sides same. On the left hand side the base is 10. On the left hand side the base is 10. On the right hand side we have to somehow create a base 10. So we have now so this is, if you this is 10 to the power minus 1 multiplied by 2x minus 1, because we know that x to the power, a non-zero rational number x, and if x is a non-zero rational number, then x to the power m, that whole raised to the power n, is equal to x to the power m multiplied by n. And on the right hand side, if let's 5 raised to the power minus 3 means 1 by 5 raised to the power cube, and we already have in the denominator 2 cube. So another concept is that x to the power minus m for non-zero rational number x and some integer m, x to the power minus m is nothing but 1 by x to the power m. So this is equal to 1 by we have uh, 5 cube multiplied by 2 cube. Now this implies 10 to the power, we have in the power we have minus 1 multiplied by 2x minus 1, that gives 1 minus 2x. 10 to the power 1 minus 2x is equal to, now 1 by, in the denominator we have 5 cube multiplied by 2 cube, that becomes 5 multiplied by 2 whole cube. From the laws of exponents, we know that x to the power m multiplied by y to the power m is equal to x multiplied by m whole to the power common power, that is m. So this is equal to, we can say 1 by 10 to the power cube, and 1 by 10 to the power cube is nothing but 10 to the power minus 3. So we have 10 to the power 1 minus 2x is equal to 10 to the power minus 3. So both bases on both the sides are same, and the base is 10, common base is 10. So this implies we can now equate the powers, and we get 1 minus 2x is equal to minus 3. This is a linear equation in x. If you solve it, you will get 1 plus 3 is equal to 2x. This implies 2x equals to 4. This implies x equals to 4 by 2, that is 2. So x is 2, and the answer is choice D. Answer is choice D. Okay, let's do problem number 3. The multiplicative inverse of, we have to find the multiplicative inverse of the given expression. That is, we have to find the multiplicative inverse of this. Okay. Now, you must know that what is the multiplicative inverse. So we have to find multiplicative inverse. I am in short writing MI. Please do not consider it as mission impossible. It is multiplicative inverse of Please know that multiplicative inverse of an expression of x to the power minus 1, anything of the form of this exponential term x to the power minus 1, where x is any non-zero rational number, is equal to x to the minus 1. We always raise to find the multiplicative inverse of any rational number x. Its multiplicative inverse will be, we raise it to the power minus 1. That is, mi multiplicative inverse of x is equal to x to the power minus 1. For any non-zero rational number x, multiplicative inverse of x is, we just raise the given number, non-zero rational number, to the power minus 1. That is the reciprocal or multiplicative inverse of x. So we know that this, okay, this will imply that so let the given expression be y is equal to, we have the given expression is 1 by minus 5, this whole raised to the power 2, and then again this whole raised to the power minus 2, and then again this whole raised to the power minus 1. If we consider this given expression, whatever that exponential term is, to be y, we have to find y multiplicative inverse of y. This will imply multiplicative inverse of, we have to find the multiplicative inverse of y, because we have considered the given expression as y. So multiplicative inverse of y is y to the power minus 1. this is equal to uh, now note that if the multiplicative inverse of any exponential term which has a power of -1 is equal to the base, multiplicative inverse of x to the power -1 is equal to x. This is a very important thing to remember. That is, multiplicative inverse of any exponential term of the form where the power is -1 and x, the base, is a non-zero rational number. Multiplicative inverse of x to the power -1 is always equal to the base. So multiplicative inverse of y, since we see that y, the given expression, has a power of has a power of -1. That is the outermost level of power. Power in the outermost level is -1. So multiplicative inverse of y will be equal to we can the base, the whole, the given number, which is something raised to the power -1, will be the base. Whatever the given number is, it is in the form, exponential form, where the power is -1. So its multiplicative inverse will be just the base, and just the base is nothing but it is 1 by -5, this whole raised to the power 2, and this whole raised to the power -2. Okay, now we have to find this. Okay, now this will be 1 by -5 whole raised to the power 2 2 multiplied by -2, because we know that x to the power n and this whole raised to the power n is equal to x to the power, the product, the powers gets multiplied. So this is equal to, now 1 by -5, 1 by the rational number, the base is 1 by -5, and the rational number, it is not in the standard form. The denominator is negative. It is always recommended that while working with rational numbers, you always keep the denominator positive. But perhaps it will not matter that much in solving the problems of exponents, because so this is what is, so this is 1 by, I am not making the denominator positive as of yet, so 1 by -5 raised to the power 2 multiplied, the power is 2 multiplied by -2, that is -4. Now this is equal to -5 by 1 raised to the power 4. So this is again a very important, very crucial and important, widely used laws of exponent, that x by y raised to the power -m, if the power is some negative integer, -m, where m is a positive integer, if the power is some negative integer, that is -m is a negative integer, then, and the base is some rational number of the form p by q. In this case, I have taken x by y. This will be equal to the base, the reciprocal of the base, that is in the base, which is the rational number, its denominator and numerator will get reversed, that is, it will be y by x, and the power will be positive. If it is -m, it will be m. So x by y whole raised to the power -m, where m is some positive integer, this is equal to y by x raised to the power m. So -5 by 1, 1 by -5 whole raised to the power -4 is equal to the base was 1 by -5. It will get reversed. I mean, it will the base will become the reciprocal of the reciprocal of 1 by -5, which is -5 by 1, and the power becomes 4. So now this is nothing but, we know -5 by 1 is 1. So this is -5 raised to the power 4, and this we know is that 5 raised to the power 4, Why? Because we know that minus 5 raised to the power 4, the base is negative but the power is even. We know that so this is equal to 625. 625 is the result, is the reciprocal, is the multiplicative inverse of the given expression. So the correct choice is B. Now we know that y minus 5 raised to the power 4 is equal to 5 to the power 4, because we know that minus x, if the base is negative, is of the form negative x raised to the power m, where m is any non-zero integer, it could be positive or negative. This is equal to x to the power m if m is even. So in this case, the power minus 5 to the power 4 was even. So that's why minus 5 raised to the power 4 is equal to 5 to the power 4, which is 625. Okay, let's solve problem number 4. It says if the standard form of a number is given, which is having a reciprocal of in the reciprocal form, that is, it is having a power of minus 1, that is, it is having some big number 2 and lot of zeros divided by 8, and that whole reciprocal is it is given. So then the value of m plus n. So it is given that this number, after 2 there are 6 zeros. After 2 there are 6 zeros, and this divided by 8 and the reciprocal. This, if this is on the whatever this number is on the left hand side, its standard form, this number in the standard form is given to be of the form 2 raised to the power minus 2, and then this whole raised to the power m multiplied by 10 to the power minus n, where minus n. Okay, then we have to find the value of m plus n. So from this given equation, it is not actually equation, it is given that the right hand side is in the scientific form. We know it is given that this number, scientific form or standard form, the term on the right hand side of the equality is in the standard form, and this standard form is the standard form of the number on the left hand side, that is okay. So this is this is roughly 20 lakhs. So 20 lakhs are divided by 8 and its reciprocal. Okay, so let's find out what is the standard form of this number. What is the standard form of this number? Now we have, after 2 there are 6 zeros, so we can write it as 2 multiplied by 10 to the power 6, and this divided by 8, and this whole raised to the power minus 1 is equal to, I am not writing the right hand side, I am just writing at RHS. Later on I will substitute RHS with the given standard form. So this implies that if there is a division operator, we know that this is equal to 2 multiplied by 10 to the power 6 multiplied by the reciprocal of, we know that from the division of rational numbers, x divided by y, where x and y are two non-zero rational numbers, especially y is a non-zero rational numbers, x could be 0. So x divided by y is nothing but x multiplied by the reciprocal of y, that is multiplicative inverse of y. And this is, and we know that y to the reciprocal of y is nothing but 1 by y. So this we can write it as 1 by 8. and this whole raised to the power minus 1 equals to RHS. Now this implies that this is equal to 2 multiplied by 8 to 10 to the power 6 divided by 8. I am writing it as 2 to the power 3, and I have whole raised to the power minus 1 equals to RHS. So this implies, now if you simplify, the base on the left hand side is a exponential term with the power minus 1, and the base is something. If we simplify the base, if we merge the powers of 2, we get 2, 1 minus 3, 10 to the power 6. This whole raised to the power minus 1 is equal to RHS. Now this implies 2 to the power 1 minus 3 means 2 to the power minus 2 multiplied by 10 to the power 6, this whole raised to the power minus 1. On the right hand side, we see that we have the standard form, and in the standard form we have 10 to the power minus n. 10 to the power of n is a negative, some negative integer. So we have to also convert the left hand side so that the power of 10 has negative integer. Now if we know that x multiplied by y to the power m can be written as x to the power m multiplied by y to the power m. Applying this, we get this to be equal to 2 raised to the power minus 2 raised to the power minus 1 multiplied by 10 to the power 6 raised to the power minus 1 equals to RHS. This implies the first term on the left hand side in the product, the left hand side is a product of the exponential term. The first exponential term is 2 to the power minus 2 and that whole raised to the power minus 1. So this becomes 2 to the power minus 2. Let it be in this form because on the right hand side we can see the term 2 to the power minus 2 raised to the power m. So, and this 10 to the power 6 raised to the power minus 1, we can write it as 10 to the power 6 multiplied by minus 1 is equal to right hand side. Okay. Now this implies 2 raised to the power minus 2 and then this whole raised to the power minus 1 multiplied by 10 to the power minus 6 is equal to, now let me write the right hand side which is given, which is 10 to the power minus 2 raised to the power m multiplied by 10 to the power minus n. Now we have to compare both the standard forms on the left hand side and the right hand side, and we see that on the left hand side the power of 10 is minus 6, on the right hand side the power of 10 is minus n. So this will imply we will equate the power of 10 on both the sides. This will imply that minus n is equal to minus 6. This implies n is equal to 6. N is equal to 6. Also, if we equate the power of 2 to the power minus 2, we can say that m will be equals to minus 1. So we got n equals to 6 and m equals to minus 1. So this implies m plus n will be equal to minus 1 plus 6. This is equal to 5. So 5 is the value of m plus n and the correct choice is D. The correct choice is D. Okay. I'm scrolling the solution of the video slowly so that you can take a screenshot. Okay. Let's do problem number 5. So we are given we are given that x is equal to minus 1 to the power minus 3m plus minus 1 to the power 2m, where m is a positive odd integer, where m is positive odd integer. This is given. Okay, then the value of, okay, so we have to find the value of some expression is given where we have the x in the power. X, we have find x in the power, and the value of x is given by this, where m is a positive odd integer. Okay, so if m is positive odd integer, okay, so now this will be equal to this x is the first term in this, we have x equals to the sum of two terms. The first term is minus 1 raised to the power minus 3m. Now this will be, now power is minus 3m and m is a odd integer, positive odd integer. Now if m is a positive odd integer, then minus 3m will also be a negative odd integer. It will be a odd integer, but it will be a negative odd integer, and hence this will be equal to minus of 1 to the power minus 3m, that is, this will be this. And also this term minus 1 raised to the power twice m, where m is a positive odd integer. Now twice m, irrespective of whether m is positive or negative, it does not matter, it will always be positive. If you multiply any integer by 2, it will always be a even integer. So this will be 1 to the power twice m, and the concept applied is that if you have something like x is a non-zero rational number minus x to the power m, where m is some non-zero integer, any non-zero integer, this will be equal to negative of x to the power m if m is odd, integer, and this will be equal to x to the power m if m is even integer. So this is the concept applied. So minus power, the power minus 3m will always be an odd integer, where since m is a positive odd integer, you multiply any odd integer with 3, it will always be odd integer. And in the result, that minus x raised to the power m, this will be equal to negative of x to the power m if m is odd integer, irrespective of whether it is positive or negative. It can be positive odd integer or it can be negative odd integer. Similarly, it will be equal to x to the power m if m is even integer. It could be positive even integer or it could be negative even integer. So we have this. Now we know that 1, this is equal to the first term, 1 raised to the power, any integer is always 1. So this is minus 1, and 1, this is minus 1 because we have a negative in front of it, and this is plus 1. 1 raised to the power, any power which is an integer is always 1. So this is coming equal to 0. X is coming equal to 0. So now the given expression whose value we have to find is 4 by 9 raised to the power minus 2x, and this whole raised to the power 3, and this whole raised to the power minus 1 becomes 4 by 9, this whole raised to the power, x is 0, so this becomes 4 by 9 minus 2x becomes 0, because x is 0, minus 2x will be 0, this and this whole raised to the power 3, this whole raised to the power minus 1. Now we know that for any non-zero rational number, x to the power 0 is always equal to 1. So we have 4 by 9 which is a non-zero rational number. When it is raised to the power 0, it is always 1. So we have now 1 raised to the power 3 and then this whole raised to the power minus 1. Now this is nothing but if we multiply the two products, the two layers of products, this becomes 1 raised to the power 3 multiplied by minus 1. This is 1 raised to the power minus 3, and we know that 1 raised to the power 1 raised to the power any integer is always equals to 1. So the result is 1 and the answer is choice D. The main concept to be applied in this problem was to evaluate the x, find the value of x, where x was the sum of two terms, where each term was an exponential term where the base was minus 1, the base was negative, and the power was in terms of m, and where m is given to be a positive odd integer, and minus 3m, if m is a positive odd integer, then minus 3m will always be a odd integer, because any an odd integer multiplied by any odd integer always gives an odd integer. Similarly, 2m twice m, where m is a odd integer, this will always be a even integer. Any integer multiplied by 2 always gives a even integer. So from this, from that concept, we got x equals to 0. Okay, let's solve problem number 6. Simplify. So we have given the expression is 1 divided by, and then inside the bracket we have 2 by 3 raised to the power 6 multiplied by 1 by 3 raised to the power minus 4 multiplied by 3 raised to the power minus 1 multiplied by 6 raised to the power minus 1. Okay, so this is equal to 1 divided by, first let's evaluate, simplify the expression inside the bracket. Now since we can see all the exponential terms, the base, in the base we have either 3 or 6, or it's in the rational form 2 by 3. Now the exponential term, 2 by 3 raised to the power 6 can be broken down into rational form as 2 to the power 6 divided by 3 to the power 6. Now why I am doing this? We are doing this because we can see the exponential terms 2 by 3 having base 2 by 3 and 1 by 3 can be broken down into a rational number, where the numerator and the denominator will have powers of 2 and 3, and on the remaining two products, the last two terms of this product inside the bracket, we have 3 to the power minus 1 and 6 to the power minus 1. 6 to the power minus 1 can be broken down as powers of 2 and 3. So we will get all powers of either 2 and 3, and we will then merge the powers of 2 and merge the powers of 3. Okay, so this is multiplied by, now 1 by 3 raised to the power minus 4 is 1 raised to the power minus 4 divided by 3 raised to the power minus 4, and we have multiplied by 3 raised to the power minus 1 multiplied by 6. I will write 6 as 2 into 3, and this whole raised to the power minus 1. We have 1 divided by, now okay, now so we have 2 to the power 6, and from the, okay, let's write it down first in terms of powers of 2 and 3. We have 3 to the power minus 1, we have 2 to the power minus 1 and 3 to the power minus 1. So we have broken down, we have applied the laws of exponents, that x multiplied by y whole raised to the power m is equal to x to the power m multiplied by y to the power m. Applying this concept, we have simplified 2 into 3 whole raised to the power minus 1 as 2 to the power minus 1 multiplied by 3 to the power minus 1. And in the denominator, we have 3 to the power 6 multiplied by 3 to the power minus 4. So this is equal to 1 divided by, now on the numerator inside the bracket we got a rational form. The entire expression is in the form of rational number p by q. The numerator, let's merge all the powers of 2. So we have 2 to the power 6 and we have 2 to the power minus 1. So this will become 2 to the power 6 plus minus 1, and 1 to the power minus 4 is always 1. As I have said, 1 to the power m is always equal to 1. Now 3 to the power minus 1 multiplied by 3 to the power minus 1. So this is minus 1 plus minus 1. So 2 to the power 6 multiplied by 2 to the power minus 1, we just added the powers. So it becomes 6 plus minus 1. So in the denominator we have 3 to the power 6 multiplied by 3 to the power minus 4, it becomes 3 to the power 6 plus minus 4. So this is 1 divided by, if we 2 to the power 6 plus minus 1 means 2 to the power 5 multiplied by 3 to the power minus 1, this is 3 to the power minus 2, and in the denominator we have 3 to the power 2. Now 1 divided by, okay, let's first simplify the bracket inside to have just the powers of 2 and 3. So we have 2 to the power 5 multiplied by 3 to the power minus 2 divided by 3 to the power 2 becomes 3 to the power minus 2 minus 2. So this is 1 divided by 2 to the power 5 multiplied by 3 to the power minus 4. This is equal to 1 multiplied by 2 to the power 5 multiplied by 3 to the power minus 4, this whole raised to the power minus 1, because we know that x divided by y is equal to x multiplied by y inverse, multiplicative inverse of y. Okay, so this now becomes 1 multiplied by, we can say this is 2 to the power 5 raised to the power minus 1 multiplied by 3 minus 4 raised to the power minus 1. Okay. Now, so 2 to the power 5 multiplied by 3 to the power minus 4, that whole raised to the power minus 1, I have splitted that using the formula that x multiplied xy multiplied by y, this whole raised to the power m is equal to x to the power m multiplied by y to the power m. So now this is equal to 2 to the power minus 5 multiplied by 3 to the power 4. So this is equal to 3 to the power 4, 3 to the power 4. Oh, sorry, there was a few more terms on the right hand side. Okay, so there was some more terms. Okay, so there was some a terms and there was minus 3. I'm sorry, I was just simplifying the first term. The entire expression is something plus something minus 3. So I will also need to find a. Let me first simplify and find what is this. So this is equal to 3 to the power 4 divided by 2 to the power minus 5 means 1 by 2 to the power 5. So this is this. Now 3 to the power 4 is 81 and 2 to the power 5 is 32. So this is 81 by 32. That is the first expression, that is 1 divided by something. That expression is 81 by 832. Okay. Now let's, I've written down initially that the whole expression is 1 divided by something plus a minus 3. Let's find out what is a. The a is actually this term, that is 1 by 3 whole raised to the power minus 3 minus 1 by half whole raised to the power minus 3, this whole divided by 1 by 4. Now, okay, so inside the brackets, let's simplify the expression inside the bracket. 1 by 3 raised to the power minus 3 means 3 raised to the power 3. Why? Because we know that x by y, where x by y is some rational number, x by non-zero rational number, x by y raised to the power minus m is equal to, we take the reciprocal of x by y, that is y by x, and the power becomes positive. This is equal to y by x raised to the power m. So 1 by 3 raised to the power minus 3 is reciprocal of 1 by 3, that is 3 raised to the power 3, minus similarly we will have 2 raised to the power 3, and we have divided by 1 by 4. Okay, this is equal to 3 raised to the power 3 is 27, and minus 2 to the power 3 is 8. This divided by 1 by 4. This is equal to 19 divided by 1 by 4. This is equal to 19 multiplied by reciprocal of 1 by 4. This is equal to 19 multiplied by 4. This is equal to 76. A is 76. So the final value becomes, so the result I am writing as result, which is the final simplified value, will be equal to 81 by 32, and then we have plus a is 76, and we have minus 3. So this is equal to 81 by 32 plus 73. Okay, we have to find now this. This is equal to 81 plus 73 multiplied by 32 divided by 32. We have to find the multiplication of 73 and 32. Let's find it out. 6, 14, and we have 9 and 21. So this is 6, 13, 3, 2. So this is equal to 81 plus 2, 3, 3, 6 divided by 32. This is equal to 7 and 11 and 4 and 2 by 32. So 2417 divided by 32 is the result of the, is the simplified value of the given expression. So the answer is choice C. So this was a pretty kind of a lengthy computational problem. You have to be very careful and have to be very patient to do the to simplify and simplify the given expression slowly. First you have to simplify the value inside the brackets, and then you open the brackets, and then in between you have to appropriately apply the laws of exponents. Okay, so you can take a screenshot of the solution. Okay, let's do problem number 7. Problem number 7. We have to find the value of x. We are given an equation. We can see the right hand side, it's an exponential term with the power is the power 3x. So x, the unknown term x, is in the power on both the right hand side and the left hand side. So definitely we have to convert both the left hand side and the right hand side to an equal base, where the base will be constant. There will be no unknown term in the base. The unknown term is in the power. Once we make the base same on both the sides, we can equate the power from both sides and solve for x. So let's see. It is given 64 by 125 square multiplied by 4 by 5 to the power minus 5. This multiplied by 16 by 25 multiplied by 2x plus 1 is equal to 256 by 625. Now clearly see on the left hand side, we see 4 and 5. We see 4 and 5. And all other numbers we see 64, 125, 25. All the terms, all the multiples of 5 can be easily expressed as powers of 5. We see 125. 125 can be expressed as powers of 5. We have 5 and we have 25 and we have 625. Similarly, we have 64, 4, 16 and 256. All these numbers can be expressed as powers of 4. So we will convert everything on the left hand side and the right hand side as powers of 4. Powers of 4, and hopefully we can make the base 4 by 5 on both the sides. Let's see. So this implies 64, I will write it as 4 cube, and 125 I will write it as 5 cube, and this is, we have whole raised to the power square, and from here we have 4 by 5 raised to the power minus 5, and we have 16 by 25. 16 I will write it as 4 square, 25 I will write it as 5 square, and we have this whole raised to the power 2x plus 1. And the right hand side, the base 256 by 625, the numerator 256 I will write it as 4 raised to the power 4. So 16 into 16 is 256. So 4 raised to the power 4 is equal to 256. Similarly, 5 raised to the power 4 is 625. So we have 4 raised to the power 4 divided by 5 raised to the power 4, and this whole raised to the power 3x. So this implies now a 4 cube divided by 5 cube can be written as 4 by 5 whole cube, and we have this whole raised to the power 2. We have 4 by 5 raised to the power minus 5, and we have 4 square by 5 square can be written as 4 by 5 whole square, and this whole we have power 2x plus 1. On the right hand side we have 4 to the power 4, the base is 4 to the power 4 and 5 to the power 4. 4 to the power 4 divided by 5 to the power 4 can be written as 4 by 5 whole raised to the power 4, and this again has to be raised to the power 3x. This implies, so applying the laws of components, laws of exponents, slowly and carefully you have to solve the problem. The idea is to have same base on both the sides, and since we can see on the left hand side, on the right hand side, on the left hand side the bases are all rational numbers where the numerators are all powers of 4, and the denominators are all powers of 5. So it is a clear idea. It is a very obvious choice that we will convert both the base, after converting both the terms on the left hand side and the right hand side into a single exponential term, the base on both the sides will be 4 by 5. So now 4 by 5 on the left hand side, 4 by 5 raised to the power 3, and that whole raised to the power 2 is nothing but 4 by 5 raised to the power 3 multiplied by 2, that is 6, and we have 4 by 5 raised to the power minus 5, and we have this 4 by 5 becomes 4 by 5 square, and this whole raised to the power 2x plus 1. This will become 4 by 5 raised to the power 2 into 2x plus 1. And on the right hand side, we will have 4 by 5 whole raised to the power 4 into 3x. So this implies, now we have on the left hand side product of 3 exponential terms, and all the exponential terms have bases 4 by 5. So we will just add up the powers. So this becomes 4 by 5 whole raised to the power 6 plus minus 5 plus 2 into 2x plus 1. This equals to, we have on the right hand side 4 by 5 raised to the power 12x. Now further simplifying the left hand side, we get 4 by 5 whole raised to the power, if you simplify the power, 6 plus minus 5 is 1, and 1 plus 2 into 2x plus 1 is 4x plus 3. 4x plus 3. Uh, 8x equals to 3 by 8. Okay, so if I can see that if I solve for x, I will get an answer. X, I will get x as 3 by 8, 3 by 8, and which is not in the choice. So I think I have done some mistake. Let me quickly check once again all the steps from the beginning. So 64 by 125, 64 is 4 cube. 64 is 4 cube, and 125 is 5 cube. Okay, 4 cube by 5 cube whole square. 4 by 5 to the power minus 5. 16 by 25 is 4 square by 5 square. We have whole raised to the power 2x plus 1. And the right hand side we have 256. 256 is 16 into 96 and 16. Okay, 16 square, and 16 is 4 square. So 4 raised to the power 4 divided by 5 raised to the power 4. Fine. And whole raised to the power 3x. Now we get 4 by 5 whole cube, and that again raised to the power 2, and we have 4 by 5 raised to the power minus 5, and 4 by 5 square whole raised to the power 2x plus 1 equals to 4 by 5 raised to the power 4 whole raised to the power 3x. Now we have on the left hand side 4 by 5 raised to the power 6 multiplied by 4 by 5 raised to the power minus 5, and multiplied by 4 by 5 raised to the power 2 into 2x plus 1. Okay. On the right hand side we have 4 by 5 raised to the power 4 into 3x. Further simplifying, we get the left hand side as 4 by 5 whole raised to the power 6 plus minus 5 plus 2 into 2x plus 1, and the right hand side 4 by 5 12x. Okay. Now we have 4 by 5, this is 1 plus 4x plus 2. So 4x plus 3, this is fine. 4x by 3 is fine. By 8. Find the value of x such that uh, 4x, this is cube 6, 4 by 5, 6 plus 1, 4x plus 2. 4x plus 2 and the 1, 4x plus 3. So I am getting 4 by 5 whole raised to the power 12x. So now at this stage we are having both the terms of the equality sign. They are both the exponential term, and both the exponential terms are having same base 4 by 5. So now I can equate the power. I get 4x plus 3 equal to 12x. So this implies, so this is a linear equation in x. We will get 3 equal to 12x minus 4x, which is equal to 8x. This implies x equals to 3 by 8. I am having an answer 3 by 8, but it is not there in the choice. Uh, it is not there in the choice. The choices are 3 by 2, 2 by 3, and 1 by 3 and half. Oh, 12x by 5, 12x. And so my answer is coming x equals to 3 by 8, and it is not there in the choice. So I will come to this question later on. So this is a question mark because no choice is given as 3 by 8. It is given 3 by 2. Why 3 by 2? 64 by 125. So this is 4 cubes. So 4 by 5, 6. Yes, it is fine. 4 by 5 minus 5 and 4 square. Okay. So 6 plus minus 5 plus 2 into 2x plus 1. This is my 1. 4x plus 2. 4x plus 3. Yeah, this is fine. Okay. I'm sorry I couldn't match the answer of this question is not matching with any choice. So I will come to this question later on. Let's proceed with the next question, that is question number 8. Let's do question number 8. Question number 8 saying if m and n are whole numbers, that is they are positive integers such that it is given m to the power n is equal to 121, then the value of m minus 1 raised to the power n plus 1. Okay, now m to the power n is equal to 121. We have to convert the 121 in the exponential form, and we know that 121 is 11 into 11. So the prime factorization of 121 is 11 into 11. So this we can write as 11 square. 11 square. So definitely this will mean that m is equal to m and n is equal to 2. This will imply m minus 1 to the power n plus 1 is equal to m is 11 minus 1 whole raised to the power n is 2, 2 plus 1. 10, 11 minus 1 is 10. This is 10 to the power 3, and this is 1000. 1000. So the answer is choice C. Okay, let's do problem number 9. Okay, it's again an equation is given with the unknown in both the power and the base. X raised to the power root x is equal to root x raised to the power x. Then the value of x is. Now for this kind of solving this problem, usually you will have the unknown in the base or in the power. So if the unknown is in the power, you will have to make the base same on both the sides. Then you can equate the power. And if the unknown is in the base, you have to somehow make the power same. Then you can equate the base. But in this problem, the unknown is both in power and base. So somehow you have to, doing some manipulation, you have to either make the base or the power in terms of x to be equal. So let's try to see if we can make the base same. On the right hand side, the base is root x, and on the left hand side the base is x. Now if I square, so this implies I can say I can square both sides. Square will be equal to root x to the power x and this whole square. So if you are given something like x to the power m is equal to y to the power n, I can always raise both the terms on the left hand side and the right hand side by an equal power. I can say that x to the power m raised to the power p is equal to y raised to the power n raised to the power p. Obviously p should be, ideally p should not be 0, or it can even be 0. I can uh, use any value of p. I can do this. So in the given equation, in the problem, I am taking square of both the terms. So I have this. Now the left hand side, I can say this is x raised to the this is x raised to the power 2 into root x, because we know that x to the power m, this whole raised to the power n is nothing but x to the power m multiplied by n. So I have the x raised to the power root x, that whole square will be equal to x, the powers will get multiplied. That is, the first level of power is root x and the second level of power is 2. So their product is 2 root x. So this will be x raised to the power 2 root x, and the right hand side will be I can say that this will be root x square and this whole raised to the power x, because if we have x to the power m and this whole raised to the power n is equal to, you can interchange the power, and it remains the same, that is x raised to the power n and this whole raised to the power m. So this will imply the left hand side becomes x raised to the power 2 root x is equal to, we have root x square whole raised to the power x. Now root x square is x, root x into root x square means root x into root x, root x into root x is x. So we have x, now x to the power x on the right hand side. Now we can see that the bases have become equal, even though it is in terms of x. Both the base on the left hand side and the right hand side are x. So we can say now we can equate the power. So we have 2 root x equals to x. 2 root x is equal to x. Okay. Now this will imply that if I take square, 2 root x square equals to x square is equal square. This implies the left hand side is becoming 4x. 2 into root x square is equal to 2 square multiplied by root x whole square. This is equal to x square. Now this implies 2 square is 4 and root x whole square is x equal to x square. Now you can so we will not actually solve it. We will now see trial and error, see which of the options value it is satisfying. We now try to use this equation and see which of the choices are satisfying this equation. So for x equals to 2 for choice A, for x equals to 2, we see 4 multiplied by 2 is equal to 2 square equals to 4, which is wrong. So choice A is false. Choice A cannot be true. Now for x equals to 3, we see 4 multiplied by 3 is equal to 3 squared. This is equal to 9. This is also wrong. The left hand side is 12 and the right hand side is 9. For x equals to 4, we see 4 multiplied by 4 is equal to 4 square. This is correct. So the correct choice is C. 4 is the answer. 4 is the answer. So this implies x uh, from here uh, say this implies the solution is x equals to 4. So the choice is answer C. Okay. You can take a screenshot of the solution. Okay, let's do the last problem, problem number 10. It is also given, an equation is given, and we have to find the value of k. Okay, so let's write down what is given. It is given 1 by 1 plus a to the power n minus m plus 1 by 1 plus a to the power m minus n is equal to, we have 1 plus a to the power k into m minus n, and this whole raised to the power minus 1. This equation is given, we have to find k. Now let's simplify the left hand side. We get 1 by 1 plus a to the power n minus a to the power m means a to the power n divided by a to the power m. Similarly, this will be 1 by 1 plus a to the power m divided by n, a to the power n is equal to, given as 1 plus a to the power k into m minus n whole raised to the power minus 1. Now we have applied the concept that x to the power n divided by x to the power m is equal to x to the power n minus m. Now if you simplify the 1 plus a to the power n by a to the power m, it will be a to the power m plus a to the power n divided by a to the power m, plus we have 1 plus, it's better if you put some brackets, so 1 plus a to the power m divided by a to the power n. If you do this simplification, do the addition of these two rational terms, you will have a to the power n plus a to the power m divided by a to the power n. Okay, and we have the right hand side. As of now writing RHS. Now what is 1 by, so 1 by so anything 1 by means, so we know that 1 by x, we can write it as x to the power minus 1. So this will imply a to the power m plus a to the power n divided by m raised to the power minus 1 is plus, we have over here also 1 by a to the power n plus 1 by something. So it will be a to the power n plus a to the power m divided by a to the power n reciprocal of this, and we have whatever in the right hand side. Now this is equal to, we know that if we have a reciprocal of a rational number, is equal to that rational number, but the numerator and the denominator gets reversed. So this will be a to the power m divided by a to the power m plus a to the power n. Similarly, this will be a to the power n divided by a to the power n plus a to the power m, and we have the right hand side whatever it is. If we see on the left hand side, the both the denominators are same, so this will be a to the power m. We will just add the numerators. This will be a to the power m plus a to the power n, and also common denominator is a to the power m plus a to the power n is equal to the RHS. So this implies on the left hand side we see the numerator and the denominator are same. So this will be 1 is equal to whatever we have on the right hand side given, that is 1 plus a to the power k multiplied by m minus 1, and this whole raised to the power minus 1. Now the right hand side, it's a reciprocal of something and it is equal to 1. We know that the reciprocal of 1 and 1 are equal, that is 1 is equal to the reciprocal of 1, that is 1 to the power minus 1. So if we have 1 equals to the reciprocal of something, that something has to be 1. This implies 1 plus a to the power k m minus n has to be equals to 1. Why? Because we got 1 equals to, on the right hand side we have some expression, that is 1 plus a to the power k into minus 1, that whole raised to the power minus 1. But we know that 1 is equal to the reciprocal of 1 only. So on the right hand side we are having a reciprocal of something, that something has to be equal to 1. So we have 1 plus a to the power k into a minus 1 equals to 1. From here we can cancel 1 from both sides, and we get a to the power k 0. Oh, we are getting I think there is a mistake in the problem statement. So we are getting a to the power equals to 0. Now it can any power, any exponential term can never be 0. Any exponential term can never be 0. Minus 1. This has to be 1. One is equal to 1 plus okay. So we are getting this now from this is something very uncommon. I mean we are getting some exponential term on the left hand side, a to the power k into minus 1, that can never be 0. An exponential term is always if depending on the term a can never be 0. Depending on the power and the base a, it can be either positive or negative. It can never be 0. So in the problem statement, I think the right hand side should have been correct right hand side should have been a raised to the power k into m minus n, and this whole raised to the power minus 1. So this is, if the right hand side given is a to the power k into m minus 1 and this whole raised to the power minus 1, we would get instead of this we will get that the left hand side is 1, that is fine. In the given equation the left hand side expression is coming to be 1, that is fine. So we are getting 1 equals to a to the power k into m minus 1, this whole raised to the power minus 1. And as I said that the reciprocal 1 is the reciprocal of 1. So this implies we know that the reciprocal of 1 is 1. So from this we can say that a raised to the power k into m minus n is equal to 1. So this implies that 1, and 1 we can always write any non-zero base we can write it as a to the power 0. Any non-zero rational number raised to the power 0 is always 1. So we can write 1 as a to the power 0. So this implies k into m minus n is equal to 0. Now we have to see what can the value of k be from the given choice. So what can the value of k be, so that k into m minus 1 is equal m minus n is equal to 0? This clearly implies k equals to 0. So the correct choice is B, but the problem statement, the right hand side, it has to be there will be no 1. The 1 plus should be ignored. Okay. Now coming back to the question that whose my answer was not matching, this one, let's see, this was question number 7. Let's give another try. Let's check it once more if I am doing any mistake or not. But anyway, if my answer is not coming properly, is not matching with any choice, then probably I will be doing any silly mistake in the calculation. So that is my fault, but please do not focus in any kind of calculation mistake. I hope you are understanding the process, the concepts, how I am applying and how I am approaching the problem. That is more important for you to understand. Okay, so let me quickly check once again. So it is given 64 by 125 is 64 is 4 cube divided by 5 cube. Okay, so this becomes 4 by 5 cube, and it was whole raised to the power 2. So we have 4 by 5 raised to the power 6. The second term on the left hand side was 4 by 5 raised to the power minus 5. That is fine. The third term on the left hand side is 16 by 25. That can be written as 4 by 5 square. And we have whole raised to the power 2x plus 1. So we have 4 by 5 whole raised to the power 2 into 2x plus 1. Okay. And the right hand side, we have 256 by 625. 256 is 4 to the power 4. 625 is 5 to the power 4. Okay. So we have the right hand side as 4 by 5 raised to the power 4, and this whole raised to the power 3x. So we have 4 by 5 raised to the power 12x. Okay. Now the left hand side, the power becomes 6 plus minus 5 plus 2 into 2x plus 1. That makes it 6 minus 1, which is 1. 1 plus 2x, 2 into 2x plus 1, it becomes 4x plus 3. 4x plus 3. So we have 4 by 5 raised to the power 4x plus 3 equals to 4 by 5 raised to the power 12x. So the bases are same, 4 by 5 on both the sides of the equality. We can equate the power. We get 4x plus 3 equals to 12x. This makes 3 equal to 8x. That makes x equal to 3 by 8. So my answer, I think, is correct. I don't think I have done any kind of mistake. Probably there is a chance that I have copied the problem from the source incorrectly. I might have done some problem in copying the powers, powers. So that's why my answer is coming 3 by 8, which is not matching with any of the given choices. Anyway, sorry for this problem. So this brings to an end of solving the problem set number 2, 10 good problems from the chapter of exponents. This is class 8 maths. I hope this video was beneficial. This set of 10 good problems will give you a good practice in understanding, in evaluating your understanding of the concepts of the chapter exponents. And I hope this video was beneficial. If it is so, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So every now and then I will come up with this kind of 10 good problems from all the chapters as and when I am completing the chapter. So I am completing the chapter from another playlist named CBSC Maths 8 following the textbook of R.S. Agarwal. So you can follow, you can understand the theory videos from that playlist, and then for testing your skills on the chapter, you can solve the 10 good problems from this playlist. This playlist is Maths 8 HOT. HOT stands for high order problems. So thanks for watching, and until the next video, take care and bye.